students. Today we have a new topic, standard error of the mean and standard error of the sample variance and sample standard deviation. So what is standard error? It is the standard deviation calculated from the value of any statistic, that is called standard error. Standard error of the mean is denoted by S. S is standard error of the mean is equal to sigma divided by, it is also denoted by this one, and sigma divided by n under root. That is with replacement case we are using, and also if we are using without replacement case, so standard error of the mean is equal to sigma. X bar is the notation, both are the same, and sigma divided by n under root n minus n divided by n minus 1. That is called finite population correction. Finite population, FPC, finite population correction, stands for finite population correction. That is called FPC. FPC have two conditions. There are two conditions if we are using FPC this term. In case of without replacement, n greater than n, the first condition must be satisfied, and secondly, n greater than 5% of n. So that is called FPC terms. If we are using for the FPC, to check the FPC term, we are using these two conditions. N must be greater, capital N means that population size, and small n means that sample size. There are two conditions if we are using for APC. It must be checked in case of without replacement case. Example, page number 33, 14.8. This example is available page number 33. A sample of size in a sample of size n is equal to 3 to be randomly selected without it to be randomly selected without replacement from a population that has n is equal to 5 item whose values are items whose values are 0, 3, point the sampling distribution of sample mean means x bar, and the second B part, calculate and standard deviation of mean. Also verified the property and verify that sigma square x bar is equal to n divided by n minus 1, because the case is without replacement case, so finite population correction term is used, and also we verified this property. Now the solution, we start from here. A sample of size n is selected, so here sample size given that sample size n is equal to 3, and population size, that is capital N is 5, and the populations are here 0, 3, 6, 9, and 12. These are must be 5. 1, 2, 3, 4, 5. Now the case is using all possible samples are drawn without replacement case. We know that in combination n. Here we use this formula. In combination n, as n is equal to 5, 5 combination 3 are selected. So according to the formula n factorial, n minus n factorial. That is the formula combination we are using. Here capital N is 5 factorial divided by 3 factorial and 5 minus 3 factorial. Expand this term 5, 4, 3 factorial divided by 3 factorial and 5 minus 3 factorial, we get 2 factorial. 2 factorial we get here. So this is cancelled, 2 factorial 2 and 2 we get here 10. 10 all possible samples we are needed to draw. So sampling distribution is required. So we first find the sample mean also. First we now draw some samples. Sample is required, and also we are needed sample mean. So first of all we are needed 3 sample are selected from 1. The case is without replacement. We start from 0, 0, 3 and 6. 0, 3, 6, 0, 3, 9, 0, 3, 12. Now 0 is finished with 3. Now 3 we ignore here. We start from 0 again, and 0, 6, 9, 0, 6, 9, 0, 6, 12. Here 6 is finished. We start from 0, 9, 12, 0, 9, 12, 0, 9, 12. Total must be drawn samples are required 10. Now 0 is finished. Now we start from reverse process is not possible. So we are going forward. We start from 3, 3, 6, 9, 3, 6, 9, 3, 6, 12, 3, 6, 9, 3, 6, 12. Now 3, 9, 12, 3, 9, 12, 3, 9, 12. Similarly, now we start from 6, 6, 9, 12, 6, 9, 12. Now these are the total possibilities of all possible sample 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the samples we have drawn. There are 10 samples in case of without replacement, and also we find the mean. Means we know that summation x divided by n means that the first process we are doing 0 plus 3 plus 6 divided by 3, we get here 9, 9 divided by 3, we get 3. Similarly here 0 plus 3 plus 9, 12, 12 divided by 3, we get 4, and here 15, 15 we get 5 divided by 3. Here is also 15, we get 5 and 18, 0 plus 6 plus 12, 18, 18 divided by 3, we get 6. Similarly, here is 21, we get 7, and here 9 plus 9, 18, 6, and here 9 plus 20, and here we get 7, and here 15, here 15 plus 9, 12 plus 12, 24, 24 divided by 3, 8, and here is 18 and 18, 18 plus 9, 27, 27 divided by 3, we get 9. Now, these are the sample means we have now sampling distribution are required. In the first part, we are doing sampling distribution of sample mean. Sample mean. Sample means x bar. X bar we have already done. Now we are finding probability. Sampling distribution means probability we are finding. Here the smallest value is 3, 3, 4, 5, 6, 7, 8, 9. Frequency means here the number of repeated values. How many? 3 is repeated just only one time, we can write 1, and 4 is repeated just one time. Similarly, 5 is repeated 2 times, so frequency is 2. 6 is repeated 2 times, frequency is 2. 7 is repeated 2 times, 2. 8 is repeated just only one time, and 9 is repeated just only one time. This is the frequency of the sample means. Now f of x bar probability of each sample is 1 divided by 10, and here 1 divided by 10, 2 divided by 10, 2 divided by 10. Similarly, here is 2 divided by 10, 1 divided by 10, and 1 divided by 10. Probability must be 1, otherwise our question is wrong. 1 plus 1, 2, 2 plus 2, 4, 6, 8, 9, 10 divided by 10. The probability must be equal to 1, otherwise the question is wrong. So our question is correct, probability must be equal to 1. Now the sampling distribution are required, so this column and this column are required multiply to each other. X f of x bar, if we multiply this column, 3 multiplied by 3 divided by 10, 4 multiplied by 1, 4 divided by 10, and 5 multiplied by 2, 10 divided by 10, and 6 multiplied by 2, 12 divided by 10, and 7 multiplied by 2, 14 divided by 10, 8 multiplied by 1, 8 divided by 10, 9 divided by 10. Now here is required sum. Sum means total. We can also write total. Sum, sigma stand for summation, and frequency is must be here 10. And now we add these results. If we check this result, if we add this result, so the result is 60 divided by 10. Another columns for the variance. Variance is also required. If we drawn for the variance, x bar square f of x bar means this result we take square. X square means 3 square. 9 multiplied by 1, 9 divided by 10. Similarly, 16 multiplied by 1, 16 divided by 10. 25 multiplied by 2, 50 divided by 10. Similarly, 36 multiplied by 2, 72 divided by 10, and 49 multiplied by 9, 98 divided by 10, and 64 multiplied by 64 divided by 10, 91 multiplied 81 divided by 10. If we add this column for the variance, so mean of x bar is equal to expected value of x bar equal to summation x bar f of x bar according to the expected value of x bar. So already done, we have this column 60 divided by 10, so the result is equal to 6. Now, if we check this property, mean of x bar is equal to mean in case of without replacement case. So, mu here means that summation x divided by capital N. X is already given that x is 0, 3, 0, 3. The value of sample 0, 3, 6. What is the values? 0, 3, 6, 9, 12. 9, 12. These are the samples. For example, 0, 3, 6, 9, 12. Now, if we add this column is required, adding summation is required, and x square for the variance is also 0, 9, 36, 81, and 144. Now, add these columns, we get the answer 10 plus 20 to 10, 10, 13, 13, 17, 1 to 70. To summation x divided by n. Summation x is equal to 30, 30 divided by 6. N is sorry 5. N is 5. Divide to each other, we get the answer is 6. Both results are same. So expected value of x bar mean of is equal to 6 in case of without replacement. So both results are equal. We verified the first property. Now we want to prove that sigma square of x is equal to summation x bar f of x minus summation x bar f of x bar ka whole square. We want to check this property. This property we have already done. 390 divided by 10 minus means already done. We have square. So the result is both are cancelled. 39, 39, 36. We get the answer 3. Now for the population we are checking here sigma square divided by n minus n divided by n minus 1. This property we want to prove here. Sigma is required. First of all, we find sigma summation x square divided by n minus summation x divided by n whole square. This is the formula for sigma square. Summation x square is 270 divided by n is 5 minus summation x already we have done 6 whole square. Now sigma square, if we cancel this one, 1 multiplied by 5, 25, and here is 20, 54. 54 minus 36, 36 if we subtract this result, 4, 14, 14 minus 6 we get 8, and 4, 18. Sigma square is 18. Now substitute the result in the above formula. Sigma square divided by n minus n divided by n minus 1. So sigma square is 18 and n we get 3, n minus 5 minus 3 and 5 minus 1. So this is cancelled to each other 6 and 2, there is 5 minus 3 we get 2 and here is 4 and here is 4, 2, 1, 2, 2, 2, 1 and 3. So the result is 3. So both results are same. So we will verify that sigma square is equal to sigma square divided by n to n minus n divided by n minus 1 is equal to 3. Thank you. Going step by step. This is the C course of I am using Sher Muhammad Chaudhary book, Statistical 1, Part 2. that is very important for BEC, BBA and master level students, that is required in the first paper. Thank you very much. Please subscribe my channel.